Hello guys, welcome back. So now we're going to talk more about SQL Union, Group By and other things. Previously, we have been talking about joins and all other aspects of SQL. So hopefully that concepts have been clear. Let's proceed further and talk about Union. But before we go further, if you've enjoyed so far, don't forget to hit that subscribe button. Give us some respect and love. Now, SQL Unions basically work with where clause and where we go here we go sorry so SQL Union are operators. Basically they use to combine the result set of two or more select statements. Okay, so as the union name specifies and suggests, SQL Union operator is used technically to combine two different queries. So for example, if you have two different SQL select statements and they return some content, we use union to combine them together and present them in one single table. Okay, that makes sense hopefully. So every select statement within union must have the same number of columns. That's the one condition. So whenever we're using union, for example, if select statement first has two columns, the second one also needs to have two columns. That's how they match the data. Otherwise we could have some problem, right? The column must also have the similar data type as well, because they're going to put the data in the same column name, so the data type needs to be same. Makes sense, right? The column in every select statement must also be in the same order, so the order must also be same. So these are three very strict rules that we need to follow for the union statements. Anything else, it can create a problem for us. So what it means is basically that whenever you're using union, make sure the number of columns are same, the column data type are same, and the sequence are same. These three things are essential. The typical syntax of select of the union is that we use the select column names. Again, remember column names must be equal in both the select statements, data types, and so on and so forth. So we say select column names from the table 1, union select column names from the table 2. So we basically use a union keyword between two select statements. What it does is it combines all these data together and presents in one single table. Similarly, we have something called union all syntax. The union operator selects only distinct values by default. Okay, distinct value means those values that are not duplicate or that are not unique in both these tables. Okay, so if there are like two, it just selects one distinct values. To allow all duplicate values, you basically use the union all feature. So if you do use union, only the distinct features, meaning if there are two values that have same data inside it, they will just be combined and presented as one. That's a distinct value means. But if you want both to appear separately, you basically use union all as a keyword. So we say select column ones and from the table 1, but we need to use union all as a keyword. Okay, again this is with the space. Then we say select from column 2. So whatever data is here, all will be union together. Let's see a demo of this to understand this thing in much better way. So assumingly we take two different tables. We have table A customers and table 2 suppliers. Okay, we have been using these tables throughout our examples. So when we do union, here's how we do it. So we say, hey, select city from customers table, union it with select city from suppliers table, and then order them by a city name. So again, we can use order by or additional parameters with this query as well. So when you execute this query, what hopefully it will do is it will combine both the names from this thing and give us all the distinct column city names in our setup. Okay, this is what it does. So if to get the data from two different tables and represented on a single table, we use this union keyword. And if you use again similarly union all, it will make sure that those column names that are repeating itself are removed, are also displayed to us, and we get much larger data set where we have multiple column names appearing in similar form. So same data is being repeated multiple times. Okay, so this is what union all will do. Similarly, union with where clause. So we can say that we can use union with the where clause. The following SQL statement returns the German cities only distinct values, because we're using union from the customers and the shippers table. So we say select city from the country, select city and country two column names from customers table, where country is equals to Germany. So we just want to see the city and country where the country name is Germany. Union it with city and country. Again, column names are same, sequence is same, the data type is same, and the number is same, right? So we make sure we follow the standard rule of union. And then from suppliers table. So this is a different table, this is a different table, but it has the same column where country is Germany, and we order them by city name. So now when we execute this query, what basically means that we are taking the city and the country, city and the country, but from two different tables, just to compare them, just to see the value and how the results are behaving. Okay, so this is what basically a union does for us. And union all with a where clause again does the same thing. So you can use a standard query again. So this basically means that this is a standard query, so all the previous rules will apply here. All what we have discussed so far, you can write any form of query, you can union with another query, so all the results of both these tables become same. The only example or any condition that we need to follow is the name of the columns must be same as we column, the number of columns and the data type must be same. Okay, so here's another example of a union. So what we're doing is the following statement lists all the customers and the suppliers. So we say, hey, select customers as type, contact name, city, country from customers. So we have used the customer as type. Okay, and then we say union them with supplier, contact name, city, and supplier. So what this will do, that it will combine all the data from customers and suppliers and give me all the data here. So because we are using customer as type, so we get the type as a customer. Okay, so this is a fixed data type column that we have specified here, that hey, there's a type which is column name, and this is a customer. So every value has a customer, 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 customer. This is one way of giving a static data inside in your column just to make content more readable. Then we say more importantly, contact name, city and country, contact name and city and country, contact name, city and country, contact name, city and country is there, and then we say voila, join them together. So these data is basically being combined from two different tables presented in one single form. So this is what union allows us to do. So it says, notice the as type above, it is an alias. So as type above is alias, and SQL aliases we use for table names or column temporary names. So this is what basically it's doing. Okay, so this is what we call a simple union is. Hopefully that concept clears it. Then we have something similar we call group by. Now, group by statements groups rows that have the same value into a similar rows, like find the number of customers in each country. So we can say that find the number of customers in each country. So we group them by, so that we can easily find out that how many customers exist within each country. So obviously in our orders, we have orders from multiple different customers belonging to different countries, but we want to just sort them out or view the data based on countries. So here we use the group by syntax. Group by statement is often used with aggregate functions, so such as count, max, minimum, sum, average, to group the results set by one other column. Okay, so we use this with these aggregate functions as well to get more consolidated data and get a result set. Okay, so the way we write it is we say, hey, select column names from table where a specific condition is there, and then we can use the group by column names, and so on and so forth. Okay, so this basically means that we are combining that, hey, column name, whatever we want to name it, just group them by, and then we can use this thing. Obviously order by is also there, this just for sorting purpose. So demo, let's use this database again, customers table we have available. How we're going to do it, we're going to say, hey, select count customer ID. So this is again aggregate function count. We have talked about count in previous sessions. So we're going to say, let's just count it. Okay, so we say, hey, count how many customers are there, country from customers. Okay, so we're going to say from customers table, find out the number of customer IDs that and customer and the country, but group them by country. So what this will do now is that it will group them by country and then count all the countries that are there that belong to that customers. So if I go inside here and execute the query, so this will give me hopefully the count. So it says count customer ID because we have not used any alias name for this. So it's just going to give us the same function return. That's why we usually put up the alias names. So we get the nice column names for that purpose. But anyway, so here what we're doing is we're saying group by country. So group by country. So if there are 3 people from Argentina, group them by under one country name Argentina and just give me the count of that country. So this is an easiest way of finding out certain number of records based on certain column names. Okay, so if I have a country, and now you can see every country is unique, but we have grouped them by this thing, customer ID. This basically means that now we can easily count how many people are belonging to each country in my database, how many orders are coming from each country in database, and this can be used for multiple purposes. So group by is very nice feature where you can very easily group the content with aggregate function count. So it's going to group as well as doing the counting as well. Okay, so we can easily use that. So the example, the following SQL statement lists the number of customers in each country sorted high to low. So now we can use the sorted order by as well. So same from code, but this time we have say, hey, order by count. So counted by customer ID and in descending order. Now this is something we don't use before. Order by, we talked about it. This is a sorting mechanism, but we are going to say, hey, order by the count this value. Why we have used function here again? If we have already used it here, but remember this function will only execute at this point. This does not exist in the database. So when we're going to say order by, we usually give a column name. So column name, how do we know that which column name is there? Okay, because this is our custom column name. This is what we did here. This is our custom column name. This does not exist. So we are actually using the same function again. So we are saying order by, but again do the counting. and now sort them in descending order. So if I use this code again and click on this, so I will now get in a descending order from highest to lowest the count of the data. So in this case, previously they were all just randomly done based on the country counting, but now I have given order by clause and I've said, hey, I order by, but because I've used this column as a new column and that counts the customer ID, I've provided this code again. So again count it, but then based on the counting, sort this data out. If you don't use ascending, it will just use high to low values, or so low to high values, so from 1 to forward. Okay, so this is what basically group by does. So if you use another example here, try to understand how we use group by with joins. So we say that consider this database below. Again, we have this table and these two tables. So we're going to say group by with joint. So the following statement lists the number of orders sent by each shipper. So now we're going to find out the data about each shipper and the number of orders they have. Okay, so we say select shipper.shipper name, the name of the shipper, count orders.order id. Again, orders.order id means that this is the table name as a prefix, dot operator connecting the column name. So there is a column called order ID inside order tables, and I want to use that. If you want to use this direct approach, then usually we do that because whenever we use join, we use two tables. So it becomes confusing which table column you are referring to. So that is why it's always recommended that you use the table name as a prefix. So we are using table name here. We are telling that, hey, there's a table called shippers. Dot, go inside that table, find out the shipper name. Then go inside the orders table dot order ID. So whatever ID is, count that. Okay, as number of orders. And now because we have used counter and I don't want to see this as count this whole blah blah function, so we are using alias here. So as number of orders, so just put them as number of orders so it's more readable and understandable from the orders table, and left join it with shippers. Okay, so it's going to give us all the data from orders plus the shipper on orders.shipper id is equal to shippers.shipper id. Okay, so find out the orders in the shipper id, make it equal to shipper id from the shippers table. So it's going to compare, and wherever the record are equal, if the condition is satisfied, that data will be joined from the shippers table with the orders table as well. But then we have said group by shipper name. That basically means that we want to group them by shipper name. So we want to identify each record uniquely. So once we execute this query, what we're going to get is the shipper name. So we have only 3 shippers. So it's going to group them and then find out how many orders each of these shippers have. Since this is two different tables having two different type of data, but we have used a complex query to combine multiple things together. So we have first used join to get the data from shippers table as well as from the orders table. Then we have used the group query to group the shipper name and count the each order placed by this thing. So this is how we break things up together. Okay, so this is simply we write the queries again. To understand it, we say that we are combining data from shipper as well as count table. We are trying to find out how many orders have been placed by each shipper, or how many orders have been given to each shipping agency. Okay, so we're taking the shipper name from the shipper table and we are taking order ID from orders table. But because we want to know the sum, that's why we have used the count here. So this is going to give us the count here. But because we don't want to repeat this thing, so what happens if I don't use group by? Okay, so if I don't use group by and just use this point here, if I run the SQL, it's going to just say the first thing, express query, and then combine here. Okay, because there are just one simple condition. So this is what it basically does. So you see, we don't get the proper results. But then when we use the group by function, now we're saying, hey, group by each shipper name. So now when I use it, it's going to come back, take all different shapes, all different name of the shippers, and then give the data separately. Okay, so that's why sometimes it's very important when you're using joins to also use the group by to understand exactly how things are happening, what orders are we getting. Okay, so this is what basically group by does. So hopefully it clears out some things, and we can now move on to MySQL having clause. Now MySQL having clause was added to SQL because where keywords cannot be used with aggregate functions. Okay, so with aggregate functions like count, like minimum, maximum, we cannot directly use the where clause. So that's why we need something new, and it's called having. The way it works is that we say select column names from table where a condition is satisfied, group them by column names having a condition, order by column names if you want to use that. Okay, so we are now providing two different conditions here, one using the where clause and one using the having clause. Let me show you an example to clarify a few more things. So now what we're doing is that we're considering this database here. So we have one table. Okay, inside this table we say, hey, select count customer ID. So count all the customer IDs and show me the country. Then from customers, from this table, group by country so that we can easily find out that which customer is from which country. Having count customer ID greater than 5. Now, what this basically means that we have used another condition here and we have said, hey, once you do the count of customer ID, make sure that customer ID is greater than 5. So once this is executed, what this will basically mean that I want only to see the customer ID that are greater than 5. So if I don't use this, Control X, run the query, now I get all the data. Okay, all the data of all the customer ID based on every different country. But I just want to see for those records that have higher number of count. Okay, so this count technically cannot be written in where clause. So we are using another condition called having, and we can use this having to find out that if customer's ID is greater than 5, show me the records of only those persons. So now all those records who are above 5 are basically shown to us. So this is what having allows us to do. So the following as statement lists the number of customers in each country, sorted high to low, only include countries with more than 5 countries. So now same query, but you can also use sorting. So in this case, you can see they are not sorted out. So to sort the content out, we use something called order by. Again, because we are basing on the count ID, which is counting the customers on the runtime. So at the runtime, we again using this whole function again that we did here, and we say, hey, just make sure it's in descending order. So once you do that, now if I just append this line here, come back, v, and remove the semicolon. So now what it will do, it will sort the data in a descending order. If you don't write the descending keyword, it by default will sort it in ascending order. So if I use it, it uses the ascending order. Okay, so order by sorts the data, but then we again need to provide that we want to sort it by the customer ID. Capiche? Hopefully that clears the thing out. So let's do one more example of it. So for example, below is a selection of two tables. One is order table and employees table. So we are having trying to use having with join now. So now what we're doing, and we're saying that, hey, go into the employees table, get the last name, then count orders given by each of the customer as number of orders. Okay, from orders table, so we are using from orders table, inner join employees on order employee ID. So we are just trying to combine them that, hey, this is an employee ID, this is the order ID. Employee ID has a foreign key, this is the primary key. So I want to find out the employees that have registered more than 10 orders. Okay, so I want to know which employee has got more than 10 orders. So if I'm, for example, building a library book, I can say, hey, which student has more than 5 books? Or if I'm building, for example, another shopping application, I can say which user has bought more than 4 items from my shop or from particular country. So to find out data between multiple things, this is what we do. So we are combining and writing more complex form of queries in which we are using inner joins, and then we are trying to find group them, and then using having counter kinds. Okay, so this is trying to say that, hey, found the last name, found each order placed by this ID. Okay, go into inner join. So join it with employees table, order employees ID is equals to employee ID. So match the employee ID with this employee ID. So match 2 and 2. So when these 2 and 2 become same, that means that employee has placed an order. Okay, so that's what basically we are targeting. So we're going to say, hey, match the employee ID with the employee ID here. If it exists in this table, means the user has put the count. That's why we use the inner join. So all the data from table 1 with the similar data of both the tables is presented. Then we say group them by last name. That's the key thing here. That's where we can find out that which employee has placed how many orders. Okay, so using group by and the count function, we can easily find that. And then we say having count orders greater than 10. So I just want to see that this which order you come has customer has more than 10 orders. So don't show me anything less than that. I just want concerned with more than 10 orders. So here's the thing, we have a last name, and because we have used them the group by, so all group names are there, and then we have placed the orders in this case. So it's not telling us that this guy has 42 orders, this guy has 104 orders, this guy has 1 to 3 orders, and so on and so forth. So this becomes a more complex form of queries where we have used select and we extracted the data from two tables, And then we have said, hey, count how many orders have been placed by each author. So group by will allow us to find that each person has how many records in a different table. Okay, so this is basically how we do it. And then we can say having count, this again is a condition where we're going to say that when count id is greater than 10, or any other condition that we can write here to satisfy that example. Okay, so in another case, let's have this one more example. It says that the following SQL statement lists if the employee Divalo or Fleur have registered more than 25 orders. So now we're trying to find out specifically. So this is where the where clause now comes into play. So we are using where last name is equal to Divalo or last name is equal to Fuller. Everything is the same, but now we want to find out, hey, what about these two guys? Have these two guys placed orders more than 25? Okay, we want to search for specific records of a specific persons. So now we are using group by last name, and we are searching for Divalo and Fuller only, and we are trying to say, hey, get the records for these two, join it with the previous employees table, and give me what we call the number of orders which are here, which have been counted as order id. Ipish. So this basically does that. So in this case, again, we are fetching the records from two different tables. One is called last name, one is called order ID. We are saying count all the order IDs placed by this person. Once you count them, group them by last name, so that I don't want the repetitive names. So when we group them, it will automatically group the Divalo and count all this data here, because we have used the count information here. Okay, and because we are using inner join, that basically means that we are using two different tables, orders and employees. So some data is coming from employees and some data is coming from orders. So two data are being displayed from two different tables combined together using what we call inner join and group by. Okay, in this case we are saying having count more than 25. So that means if orders are more than 25, then show me. I don't want to be concerned with anything less than that. Capish? Excellent. So now let's talk more about exists. Exist operator is used to test for the existence of any record in a subquery. Okay, this is different from what we have done up till now. This is trying to find out that does this exist operator tests whether existence of any record in a subquery exists or not. So exist operator returns true if the subquery returns one or more records. So it basically returns only true or false. So the way we write it, we say, hey, select column name from this table where exists. Again, select column name from table name where condition. So we are using another query as a condition to find out whether the record that this table returns me exists in this table or not. So basically we are again trying to compare and analyze whether the record existing in one table are updated in the second table or not. Sometimes this works in best when we are updating multiple tables and we just want to validate whether this record has been updated or not. So let me give you an example to understand this thing better. So for example, we have a table called products and we have a table called suppliers. So we say we want to verify that the records have been updated correctly or not. Okay, so we say the following SQL statement returns true and lists the suppliers with the product price less than 20. So we are saying, hey, select supplier name from suppliers table where exist the product name from products table, the products dot supplier id is equals to supplier id from the supplier table. So first what we're going to do, we're going to check whether this supplier id exists in this table or not. So this is our main suppliers table, and when the our product was placed, has that supplier id exist in this table or not? If exists, that means the data has been inserted and some information is there. If it does not exist, it returns false, means hey, this table does not contain any order based on this particular id. So this is what it tries to do. So this is why the where clause is. Okay, so and then because this is in a separate table, so we are using nested query to find out information for that. So if I execute the query, now this is what basically we get 24 records. We are trying to say that select supplier name, so we get the supplier name here from where exists. We basically doing the evaluation whether the information returned by this query alone exists in this query or not. If it does, then give me the name of that. Okay, so this is what exists allows us to do. So if I come back here again, let's do one more example. It says that the following SQL statement returns true while the supplier list with product price equals to 22. So now again it is equal to 22, or in this case less than 20. So in this case all those records that were less than 20 will be returned. What if I just want to say equal to? This basically means the price is equal to 20. Return those records for me. So only one record we got. Okay, So exists basically allows us to do that. So using exists, we run a query on a different table, get the data, and find out that that information exists in the primary table or not. Okay, so using exist brackets, and then we write a standard query. So this can be a standard query with any information that we want. It can have select, you can use inner joins for that matter as well, and then check whether the data exists from this table or exists in the second table or not. When we are having more complex form of data and more complex form of relations, we need to verify and validate and see whether data exists correctly or not. So this is where the exists are used for. Then moving on further, we have something called SQL any and all. Okay, so any and all are operators that allow you to perform comparison between single column value and a range of column values. So this allows us to do that simple comparison. So using any and all operators, we basically are able to do and perform a comparison between single column value or a range of values. So for example, the way we use any is that it returns a Boolean value as a result, returns true if any subquery value meets the condition. Okay, so the way we write this is that we say that select column name from the table where condition is used, where column name, operator, any, and then we use any of the select subquery. So which again says the returns Boolean if that exists. It means that the condition will be true if the operation is true for any of the value in range. So whatever is existing here, it tries to say that whether this value or range exists in the second column or not, is a comparison between those two. So the operator must be standard. So this operator is there, this operator is basically using it. So the operators are basically standard, like equal to, not equal to, greater than, less than, and so on and so forth. So we say all operators, the all operator, again instead of any, if you use all operator, it returns a Boolean as well, returns true if all the subqueries values meet the particular condition. So when we write a subquery, if they meet the condition, it returns true, is used with the select, where, and having statements. So how we use it, we say select all from column names from table name where a condition is specified. Okay, select all syntax with where or having. So if you want to use with that, we say select column names from table name where column name operator all. Okay, so in previously we used any here, now we are using all here, and we are using subquery here. The operator is key thing here. The operator must be a standard comparison operator. Let's do a demo of it to understand this concept a little bit more in better. So now we're going to say, hey, assumingly we have two tables called product and order details. So we write a query for that. Now what this query is going to do, it says that the query lists the product name if it finds any record in the order details tables has a quantity equal to 10. This will return 2 because the quantity column has some values of 10. So it says that find out the product name from the order details that has quantity equal to 10. Okay, so I want to see that which quantity is 10. So this is how we write it. We say select product name from the products table where product id is equal to, see this impair, this is the operator that we are using here again. So inside the where clause, we use the operator equal to any means any record returned by this query. So we are trying to see that whether this product exists in this table, that exists in this table or not. So we say any select product ID from the orders details where quantity is equals to 10. So go inside the orders details table now, again another table, find out the product ID, again this is the product ID here, and find out the product ID where quantity is equals to 10. So all those records that have quantity 10, return those IDs for me, and then we're going to do that comparison equal to here. If you run the query, this is the result that we get. So all these have what we call the product names, have quantity of 10 in our database. Okay, so if I come back here, this is what it means. So we're trying to find out the quantity of each product, but product name is in another table and the quantity is in the table. It has been normalized. So this is a table that contains the product information, and this is the order details, that which product has been ordered. So in a typical online shopping, this is how basically we try to manage the content. And we say, hey, order details, so I have an order ID, and this order ID contains the order that has been placed in the order ID table. Product ID table is basically linked here. So this product ID is here and this product ID is here. So we are basically using these two IDs to do that comparison. So it's trying to find out the product ID in any case where the quantity is basically 10. So return this product from this products table, and then we do the comparison equal to. So this is basically what we exist. The following SQL statement returns what we call or searches for the product name if any records in the order detail table has quantity larger than 99. So if you use this one now, does the same thing, but this time it's just using greater than symbol. And then again, it does the same thing. Go inside the product ID, uh, in the product details tab, find where the quantity is greater than 99. So once all these records are returned to me, we use the comparison, and we say that find out the same product ID that we got here. Does that product ID exist in the product name or not? If it does, then return those tables for me, and now I get this value. Okay, so this is what basically our product name does. And similarly, you can do multiple different comparisons to find it all. SQL all, if you use this query instead of just what any, all will basically means that it returns lists all the product names. Okay, so select all product names from the product where condition is basically true. So all the product names will be default given to us. In other words, all the records of 77 will be returned. So in the product table we have 77 records. All the records are represented because we have said select all. So give me all the data of product names where condition is just by default true. Okay, and then you can complicate and enhance this theory. So for example, in this case we say select product name, products table where product ID is equals to all, but product ID matches with quantity of 10. So for those whose values are 10, give me only those records, and then show this in the table. Okay, so all the tables, all the data will basically be shown that have exactly 10 quantity. So in this case, no record is shown because probably there's no record available that has 10. Okay, so not only 10 value. So this is what any or all basically allows us to do. So hopefully you understand